And symmetry means that you can take a line and cut something into two mirrored halves. This is one of those things where it's hard to explain but simple when you see it. Halves, 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 H-A-L-V-E-S, halves. Three halves and the halves not. For example, and a lot of things in this world are symmetrical, you pretty much are a symmetrical being. Now, obviously, there are exceptions to that and things like that, but if you were to take a line and cut yourself right down the middle, okay, one half is a mirror image of the other half. When we look at shapes, for example, a rectangle, how many lines of symmetry would a rectangle have? How many different ways can you draw lines that cut it in half? So when you fold them upon themselves, well, it's pretty simple. You know that you can cut it like this, and you can cut it like this. Are there more?
No.
There are not. Some people think diagonals are, but diagonals are not, because if you take a rectangular piece of paper and you cut it, you draw a diagonal line. Here's a good way to be able to tell that. And you take a diagonal line like this. Okay, there's your diagonal thing, but when you fold it, they don't match up. So no, rectangles don't have any other ones than those two, but squares, ladies and gentlemen, if its four sides are all equal, a square has a vertical, a horizontal, and two diagonal lines of symmetry. A square has four lines of symmetry. Rectangle only has two lines of symmetry. You have to be careful. Something like if it's an isosceles triangle, how many lines of symmetry would an isosceles triangle have? Which way can you split an isosceles triangle some way? Way
Down the middle.
down the middle. Cut it in half. You can't cut it this way though. But if it was an equilateral triangle, all sides are equal, then you can split it like this, you can split it like this, and you can split it like that. You have three lines of symmetry there. And then what about a circle? Lines of symmetry for a circle. Well, you can cut it like this. You can cut it like this. Are there other ones?
Yes.
Go diagonal. Are there more?
Yes.
And any place where you have a diameter that goes through the middle. There are an infinite lines of symmetry. So they go on to find to talk about rotational symmetry. Oh yes! And then we also have to talk about one more thing, which is called rotational symmetry. In rotational symmetry, I'm going to list my little help here. Rotational symmetry means this. If you can take a shape, if you can take a shape, and when you spin it, when you rotate it, if it ends up being the same exact shape before you spin it all the way around and make one whole revolution, it has rotational symmetry. See, this one I only had to do it a quarter turn. It does it again at a half a turn. It does it again at 3/4 of a turn and at a full turn. A square has rotational symmetry. If you had a triangle that looked like this, copy it again too, just so we can, please. if you have a triangle, and you spin it, okay? When it gets to here, is it exactly the same? No. When it gets spin 180 degrees, it's upside down, still not the same, still not the same. It doesn't become the same until you spin it 180 degrees, so this does not have no rotational symmetry. So if we looked at some things, let's look at the letters of the alphabet. A, B, C, D, E, F, G, H, I. Which one of those, how many of those have rotational symmetry? Or do any of them have rotational symmetry? Okay,
2,
which one?
H,
I believe you're right. I think I have to draw my H like this though first. Just so I can do it in one thing here. Yeah, H, if you spin it a half a turn, ends up being an H. And I, same thing. If you spin it half a turn, it becomes an I. As long as it does it before a full turn, because everything has rotational symmetry if you go a full turn. Now, which one of these has just right normal lines of symmetry? Does letter A have a line of symmetry? Yeah, right down the middle. A letter B, depending on how you draw it, you might, if you drew the lumps exactly the same, you have a line of symmetry right here. Symmetry on a C, again, depending on how you draw it. D,
Yep.
E, F,
No.
nothing. G,
No.
H would have how many? 1, 2. I, 1, 2. H wouldn't have, unless it was a square H, it wouldn't have a line of symmetry as a diagonal either way there. So. Perfect. All right, for tomorrow then. Looks like we're at what, 1:10.